and Direct2D. For DXVA, I'm not going to talk a huge amount of detail, but sort of HD playback is becoming increasingly important. So there are some things that we added to it to sort of keep up with what kinds of capabilities or features are required to do HD playback. So I think that kind of sort of covers the what are the new APIs and what additions that we made. And again, the goal is this is the direction that we're going in, that we want to build everything on top of these sets of boxes. Now, it kind of didn't completely end there. That we also added a Direct3D 11, and this is a place where we've kind of are trying to learn our lesson about compatibility, API compatibility. So Direct3D 10 or Direct3D 11 is the API is intended to be a proper superset of the Direct3D 10 API, and so it's relatively easy to change an application to make use of Direct3D 11. And of course, it adds some interesting new hardware features. It adds tessellation and some new texture formats, and probably the most significant feature is it adds something called the compute shader, and the compute shader is for people that are interested in doing more general programming processing of sort of data parallel applications. So what was happening is with Direct3D 10 or Direct3D 9, you would, if you wanted to go process a big array, you had to turn it into a texture map triangle rendering operation, and it just seemed kind of arcane to do this. In the compute shader, you simply write a program that operates on an array, and the array can be 1D, 2D, or 3D, and we also included some other generalizations to the graphics programming model that allow you to do scatter or to do some atomic operations. So what we're hoping is that with the compute shader, we'll have enabled developers to be able to do some more sophisticated, not your average game processing kind of stuff, but make it easier to, say, do photo processing or things that have nothing to do with pixels at all.
So basically, you're saying that do you have like we'll be able to use the GPU, or would I say GPUs, on the graphic card for multi-purpose programming?
That's right.
That's cool.
And it's something that, there's been developments that have been happening all the way along, and this is probably the most significant thing that we've done. Like in Direct3D 10, we added integer instructions and IEEE floating point formats to kind of make it more possible to do the programming. Direct3D 10 tries to change the programming model so it doesn't involve so much sort of arcane graphics concepts like drawing a triangle.
Okay. So looking forward on the next version of Windows, of the next version, what we would like to see is as developer investing in these technologies and kind of deprecating or stepping back from older technologies.
That's correct. Now, that isn't to say we're just we're abandoning them completely. We're still doing work, and I can say a few things about what we've done to GDI and GDI Plus. For example, GDI Plus had its own imaging codecs for reading image files, and there's a component that I haven't talked about called WIC, which is Windows Imaging Component, which also showed up as part of Windows Vista, and that is intended to be our one centralized way of reading and writing image files. And what we wanted to do is make that be the most secure, most robust, most featureful way of doing things. So we've relayered GDI Plus to use WIC as its codecs rather than having its own different code base for the codecs. And we're trying to get other parts of the other applications to get on top of WIC instead of having their own custom libraries. In GDI and in the sort of Windows system proper, we've done some things to try to improve the responsiveness of the system and be a little bit more multi-core supportive. In particular, there are places where we have locking to try to control synchronization to shared variables and things like that. We've tried to increase the ability for applications to be able to do stuff concurrently, and so that is going and looking at the locking that happens inside those subsystems and try to improve the distribution of locks so that they don't end up bottlenecked on a single thing. So these would be cases where you might see the ever popular green ring spinning, and what is happening is someone's holding a lock inside user inside Win32k.sys and blocking that application from making progress because perhaps some other application is paging in a bitmap or something like that. And we've tried to reduce the contention around some of those locks or make some paths be more independent. And so you'll see some amount of green rings disappear, but you're not going to see them all go away because it's kind of a hard problem. But again, what we're trying to do is these things are still first class supported in the system, and we want to make sure that those components work well.